Okay, so let's do another problem. Let's take a look and see what we have. Okay, so let's take a look at this. So it says, for what value of n will the equation 3 and in parentheses x plus 2 plus 5 in parentheses x plus 3 equals 2 and then parentheses x plus 5 plus n in parentheses x plus 3 minus 7 have infinitely many solutions. So we have these two expressions set equal to each other. You have x variables and you have the n variable. We want to figure out what n would be in order to make it so it has infinitely many solutions, right? So to have that, it was actually, if you thought of, like, let's say you could think of each side of the equation as a function or a graph, right? So like if you had these two, if the two graphs were equal, or if the two functions were equal, then they would be the same, and they would be infinitely, so there would be infinite solutions. So let me just try to show you, try to give an explanation of that, right? So if I just had a graph, right? So now let's say you just have like two lines and they just intersect, right? Two lines, they intersect. So there's basically one solution right there. That would have one solution, right? Then you could also have a case where, let's say you have two lines and let's say they're parallel, right? So then these two lines are basically, it would be two lines that have the same slope, but they have different y-intercepts, and they're just basically never going to meet. So then there would be zero solutions, right? But now the case for this would mean that, okay, let me just draw that out. It would mean, okay, so you have a graph and then you have one line and then you have another line, right, which is basically going to be the same. It could be written in a different way, but it really, ultimately, it's the same expression, same line. So basically these two lines are right on top of each other, so they have infinite solutions, right? So basically, we have to find a way to set these two sides of the equation equal to each other. So let's try to do that, right? So let's just write that out, right? So I'm just let me just write the equation to start, right? So we have 3 times x plus 2, right, plus 5 times x plus 3, and that's equal to 2, equal to 2, parentheses x plus 5 plus n times x plus 3 here minus 7, right? So basically, you just have to, you'd have to do a lot of the distribution on here to simplify this, right? So let's just basically go through all that, right? So we have 3x, 3 times 2 is 6, so we get plus 6. 5 times x is 5x, so plus 5x, right? 5 times 3 is 15. So this is the left side, right? And let's move over to the right side, right? Just distributing. All right, so 2 times x is 2x. 2 times 5 is 10, so plus 10. Plus nx. Plus n times 3, right? I can just put n 3 minus 7, right? So now what I can basically try to do is let me try to put the like terms together. So I'll put all the terms with x, right? All of the terms that have an x term in it, I'll try to put them together on the left side. So 3x plus 5x, you wind up getting 8x. Right? And then these numbers, these constants here, we'll put them together. 6 plus 15, that's 21, right? Now let's go over to the left side and we'll try to do the same thing. I'm just going to try to put all of the things that have x all together in one place, right? So, you know what? I have 2x and I have nx. So let me just write it like this: 2 plus n, right, times x, right? That's just all the x terms. So now actually, you can actually try to, figure this out right now, right? But, because I know that this 8x has to match up with this 2 plus nx, right? So you can just, set those two equal and see what that comes out to, right? But let me just continue with the whole thing. Let me just put all the number parts together as well. So then we have, well, 10, you have the 10, you have the n times 3, and you have the minus 7. Well, 10 minus 7 is 3. So I'm going to get 3, right, plus n times 3, right? Right. And then this part, this 3 plus n3 should match up with this 21, right? But let's just do this part. Let's just see that the x part, what we get, right? So 8 should be equal to 2 plus n, right? And if we solve that, well, minus 2, and you get 6. So basically the answer to this should be 6, right? And you could stop right now and say that the answer is 6, but let's just make sure everything's okay. Let's see if it works with the number part, right? So this 21 should be equal to 3 plus, now we know we said it was 6, right? So 3 plus 6 times 3. So let's see if that works, right? Well, 6 times 3, that's 18, right? 18 and 3, right? So look, it looks like it works, right? So you have 21, right? And 3 plus 18 is 21. So definitely it works. The 6 makes it, if the value of n is 6, it makes it so that both sides are equal. So basically you'll have infinitely many solutions. So the answer to this is 6. And we've done another problem. Okay. So that was a good job. Okay. All right. We finished this.